Welcome to Build Up, the European Commission's portal for energy efficiency and renewable energy in buildings. Directly stemming from the Energy Performance of Buildings Directive, Build Up is the meeting place for everyone involved in making the European building and construction sector more energy efficient. Every month we focus on a topic that is key to making Europe's buildings as energy efficient as possible. Exploring that, you can find the latest content such as expert talks, webinars, case studies and more. From architects and engineers to academics and policy makers, we've got you covered. Build Up brings together thousands of registered members to reap the benefit of Europe's collective intelligence on all aspects of energy efficiency and renewable energy in buildings. The Build Up portal benefits from the expertise of our ambassadors. Drawn from industry and academia, the ambassadors bridge the gap between EU and national level and help shape our editorial content. Want to promote your work? Build Up disseminates your research, projects and events through a variety of channels. Become a member to exchange knowledge with your peers. You can disseminate tools and resources, share good practices, and consult open source publications. Join the discussion on social media and become part of the Build Up community, or subscribe to our newsletter to receive the latest news. However you participate, the Build Up portal is here to inspire, inform and connect. Build Up, the European portal for energy efficiency and renewable energy in buildings. Join the community for opportunities and updates.
Good morning and welcome to today's webinar. My name is Katrien van der Kuilen and I'm a member of the Build Up team. It's a pleasure for Build Up to host today's webinar and workshop event titled Stakeholder Webinar Series, Building Design Teams and Building Users, Facility Managers and Owners. Today's webinar is split into 3 parts and will explore the implementation of circular design principles in buildings. The speakers will present you with their key considerations for successful circular design, energy efficiency in sustainable buildings, and the case study of a circular designed resort. Before we begin, we invite and encourage you, today's audience, to send us your questions or comments to the speakers throughout the session. To do so, please use the question function in the GoToWebinar tool. These questions or comments will then be addressed at the end of the panels. The agenda for today's webinar is composed of the following 3 sessions. Junita Kulikovsky-Kisnere is Director of the New Building School, Sustainable Construction at the Vidzin University of Applied Sciences. In the first session, she will address the circular design of buildings. Then, for the second session, Ricardo Sá, who is Director at Edifícios Saudáveis, will present the topic of energy efficiency of sustainable buildings. And then in the third and last session, Il van Christen, Investment Projects Sector Director at Valamar Riviera, will present the Valamar Amicor Green Resort. We remind you that today's webinar is organized by Build Up together with the Cost Action Project. And now, without further ado, Junita, the floor is yours, and we move to the first session directly.
Hi, hello everyone. Yeah, it's my pleasure to basically bring you into the framework of circular building design, which in most cases, in fact, is referenced with the sustainable building design as well, or sustainable construction. So the wording flows a little bit. So wherever and however you have heard about sustainable construction, sustainable design, and the circular building design is very much a part of it. In these 20 minutes, I'll kind of try to bring you into the picture of how it operates and why it operates. In fact, why, how, and what exactly. Click. Okay, I'll try with the mouse. Okay, very well. So when we talk about sustainable development, where construction falls in, and it is basically these 7 of goals or metrics and measurements where construction, and in particular circular construction, falls in and contributes to reaching these sustainable development goals. And I think one of the biggest whys to address the circular design and such matter is that construction industry, the built environment, is responsible for almost 40%, basically 40%, and let's say the number fluctuates from year to year, of annual global CO2 emissions and greenhouse gas emissions. And of course, a lot of it is into the raw material use, which is, again, I'll address as part of the circular design. A lot of it is building operations, but we have to understand that this whole built environment CO2 emissions are not just about the operations, which unfortunately mainly is a discussion topic around where we can save or where we can sink CO2. We say, okay, the operations, the energy efficiency, and so on. But we have to understand that in particular, when we address the sustainable building design, we have to understand about these embedded emissions on the way, before the operations and also after the operations side. In whole, we call it building a life cycle. So in fact, when we look at the emissions, then the mostly are presented into the embedded. And the life cycle of the buildings looks something like that. So we expect that the buildings after their end of life are actually becoming just waste, just trash, and they basically get to these waste management polygons, we could say so. And the question lays into whether this is really how we see our living space, our built space, our environment, that we produce something that becomes the waste at the very end of the life. The circular construction and building design presents these environmental benefits if we actually circle this first part of the embedded emissions, and we reclaim the materials, and this is called their, let's say, second life, third life, the fourth life, however how long we can keep the materials running into these cycles, instead of building from new materials constantly again and again. And this is where circular economy as such, as a way of thinking, way of operating, way of economy and such, presents its benefits. So just to draw a very, let's say, a short intro on the linear economy is what we mostly see, or basically unsee, because we don't see the waste in our courtyard, and that makes us feel like that doesn't exist, but unfortunately exists. So from what we take, what we make, and what we use, we basically create the waste. This is the image that I showed you. Recycling economy helps to let's say, cope with a part of the waste, but there's still the waste, and we are not very good at the recycling, unfortunately. And circular economy makes sure that, in fact, everything that we take, we use again and again, and we do not create the waste at all, or a very, very much minimal percentage, or we regain at the very end, we regain the energy from what we have wasted. Yeah. So this is a very short on how the circular economy. So I'm really hoping that these are three key elements of why, and the very reason to initiate the transition and to become the passionate about this circular building design. And this is where we turn to this ultimate wish to really change that trajectory of reality. And this is not something new. In fact, we were discussing with the colleagues that no one taught us linear economy, right? But for some reason, we have to learn the circular economy. However, it is something that has been present in history and in past, and actually in limited resources or limited industrial revolution, we were just under the pressure to use what we have, because that was just necessity. So, and here on the right side of the slides, we see the image from the Brussels, very early 20th century, the demolition site, where somewhere when we look deeper into the image, we can see the billboard actually with all the materials mapped out and quantified, and they have their price tag. So in fact, you can buy that material from the demolition site. So it's nothing new, as we sometimes hear being presented, that circular economy or circular construction is something brand new where we don't know the processes or something. We just have kind of lost to the easiest and shortest path, which is this very business as usual. Let's demolish everything and let's build something new. So the very first question is whether we actually need to build something new. And this secondary market idea in construction is again nothing new. So I really hope that the biggest why is to get from this image, and I would say if you visit one wasteland site on the construction waste, it's unforgettable experience, and once you see it, you can't unsee it. To get to the ultimate circular construction, let's say secondary market idea. And in order to do so, of course, all the mechanisms have to be in place. The tons of waste, the construction demolition waste, the CDW, annually in the world, they basically contribute to more than 1/3 of the created waste in the EU, for example, annually. And during the research in Latvia, for example, less than 5% of the construction waste in Latvia is circular, and also in a very kind of let's say questionable way circular. So they are still let's say downcycled in their potential. And when we get to the how, some keywords and some very much essence of how to look at it is, first of all, to look from design perspective, and key topic in this is design for disassembly, for new and for old and for renovations and other kinds of construction. The second is reuse. So if you have designed it for disassembly option, then to reuse the materials, and just the third level is to recycle. So again, if you have designed it so that you can split it in the parts, you can reuse it and also recycle what is possible to recycle in the new kinds of construction material or other kinds of material. Hopefully not just once, but like multiple times. So for design for disassembly, the modular design principles and construction that involves designing the buildings in the modules, prefabricated modules that can be easily assembled and disassembled. And here again, of course, it is a question of technology and engineering level, how far we are in that as well, and have we considered these modules in a systematic way to be constructed and deconstructed. Standardized connections also regard to the previous, so that's building in Latvia and Scandinavia, in UK, and somewhere in Greece. So these parts can be sourced and connected without damaging the other parts or the building itself. Yeah, that ensures that these connections will be disconnected and won't harm the elements, the modular elements that are part of the design, for example. Screws and bolts, instead of the nails, for example, can be easily removed and reused again. And here I could also say the timber taps is something that you can consider, but the timber is another topic that I'll touch upon. And especially on nails and nails and adhesives can really damage the material, the wood in particular, but I mean all the materials, and make it very much difficult to reuse. Labeling building elements and documenting. So this regards to digitalization of the buildings and construction, starting from the very much design phase into the very detail of where each connection or detailed connection or joint and how it is stick together, from what kind of materials and what kind of technology is done. This whole information allows us to reuse the materials later on, or disassemble or retrofit, for example, some elements or details or materials when necessary, so if they are broken or damaged or whatsoever. Digital logbooks, starting with, let's say, BIM, but like all kind of digital logbooks from of building materials and all information that lays into construction. For example, what is the load that this wooden timber beam is carrying, and like what is the expected time that it can carry, so that we know that on the second cycle or third cycle or whatever the cycle this wooden beam is used, what kind of load it can continue to carry. Is it still a structural element, or is it maybe interior decorative elements, depending on how much it has already done in the previous cycles. And this also allows to deploy the principle of buildings as a material banks. So if we have these logbooks and we know digitally what our buildings consist of, this in fact, somewhere heard from Ukrainian colleagues that this was something unconsidered in let's say the war circumstances, that the buildings in fact can carry a lot of necessary materials that can be used for industrial production or all kinds of production needed in those kind of circumstances and situations. This is like, of course, force majeure, but just thinking of the future and buildings as material banks, I think it's changes the perspective on instead of waste, but material banks. So instead of waste, we have a resource. So this documentation allows us to actually perform it. And from all of that, I want to touch upon circularity of wood material. This is again also my research focus, and in our regional area, let's say Scandinavia, Baltic states, we have a traditions of the wood construction. However, now pointing that you come from everywhere else and you have your regional or particular traditions. This rather shows how we turn to, let's say, history and heritage and understand the perspective on what we actually have. So auditing the knowledge, the resource, the practice, the approach in construction, what we have had. So the origins of this circularity, in fact, taking like 20, maybe 50 years back, or 100 years back in this case, and understanding what could be circulated. So coming from the very traditions of wood construction, on log house construction in Scandi and Baltic Sea region, this provides us with these methods, in fact, and access to material. I think, around 45% of the, let's say, Latvian buildings are built from the wood in one or another way. So this presents a very high potential for circularity if it is done correctly. And during my research, I understood that actually modern days, like a modular prefab kinds of wooden buildings, are less circular, or potential that they present is less circular, because there is a lot of materials that are melted together, for example, and can't be disassembled, instead of what we see in historical wooden buildings, that they can be easily disassembled and assembled in another place. Why wood and such matter? Maybe, nevertheless, that you have experience in, let's say, cement or other kinds of like clay or limestone materials. Wood has this particular characteristics, let's say, that during its lifespan, it actually collects the CO, absorbs, we could say, so absorbs the CO2. And that's why we call the timber material, the wood material, as a carbon sink. So in fact, building from the wood, we can not just get the net zero, but actually the negative CO2 building if we design correctly. So wood is a precious material in that context of circular economy, and also is in the context of the EU legislation and CO2 calculations for various certifications that will be explained and elaborated on in the next presentations. So carbon bank or carbon sink, we in the context and it's a mixed in the modern architecture and engineering, and presents enormous potential actually to save the building sector from being one of the major polluters of ecosystem at the moment. So I would really urge you to pay attention to it. In fact, here I have some numbers from the research 2020. So 3 scenarios played out. If we would build a certain percentage of the wooden buildings, even starting from new buildings. I'm not considering, in this research, they did not consider the reconstructions and renovations. So new buildings from the wood, in the highest, let's say, from minimum 10 million tons of CO2 per year to 700 million tons of the CO2 in the highest scenario, when we maximize the timber construction. So you will look at it in a detail. So now I'm gonna just give you a kind of a what or we understood the why, we understood how. Of course, it's not just about timber construction, but it is about the whole cycle, and depending where you are and where you're constructing, and do you need to construct at all. So this 3-cycle building system is a great case study. In fact, it provides you with a clear manual and why it is interesting to look at it in the detail, because in Estonia, basically the demand for new construction, the public construction, kindergartens, hospitals, is a much bigger than actually the construction sector can ensure or provide with. So the new systematic approach has to be introduced in order to understand how fulfill the demand and evolve, let's say, and develop. So it is interesting that in this system, it adopts this engineered wood, engineered timber as primary structural element, but all the other, let's say, materials and elements from different materials are also with their lowest footprint possible. And the principles and how it is designed and could be constructed is under this design for disassembly principle. So when you look really in the detail of a system, then you can actually have the whole roadmap in front of you. And what is the best about it? It's open source system, so you can actually download the guidebook, the DWGs, the BIM models, that everything is laid out to you and mapped out to you, so that you can actually adapt it. And there are also exact project, realized project examples that you can follow, for example. The circularity within it, within this three-cycle system. So basically, there are three types of the modules, that the scopes of the models that we could kind of describe with. The element, the whole building you can reuse, the module, the one like produced manufactured piece of the model you can use, and each component you can reuse. So you have the information about each let's say level of these cycles. So you have nine elements, not 9 modules in the building, and you have one to 6 modules as a part of it, and then you have a components. That's why it's called like a 3-cycle, 3-level. So when they're building room modules, and components. So in fact, I don't want to go much into details. It's just so many circular building design aspects that are implemented and laid out to you, that just go and take it. The whole preserving of the value that keeps the materials from being dumped into the landfills or regained energy in the burn matter. The whole system is designed so that the materials and elements are saved for the future use. And of course, then we avoid the necessity to extract of the resources and produce new resources, new materials. Exactly, and you can see these patterns coming up at the moment in public procurements, so kind of called 369 pattern buildings, as a dormitories, as kindergartens, as I mentioned, schools, and also not just the new buildings, but also additions or extensions of the buildings. So these pattern buildings can be from, let's say, residential purpose, like house, office, to a very much public school, kindergarten, hospital, or whatever. Every pattern building of such is mass customizable. So if the customization, like manufacturing systems, are customized, then they're adjustable, environmentally friendly, of course, and made primarily of the timber. So again, you have to evaluate what source of timber and where, and again, how much embedded carbon we collect if we don't have that material at hand. Modular and prefabricated and ready to produce, assembled and transported in most of European countries. But the whole idea lays into that this whole, like a system, this 369 system, 3-cycle building system, can be applied in almost every manufacturer, the closest manufacturer, the local manufacturer of yours. So that's that whole thing. Because usually, if in this high demand, let's say the one manufacturer would get the whole building to manufacture, it would overload its facility, and again create the, let's say, fluctuation in demand and supply. In opposite, in here, you can source these modules from various manufacturers around your, let's say, site. Okay, therefore you don't put the load on one, and it is actually decentralized in a way, and that's how you can get the faster delivery and production. And again, the system allows it to be assembled very quickly. All right, from all of the information that I could give you in this very short time, in essence, I really urge you to look into the very good toolkit that is, circular building design kind of toolkit by Arab. And very practical, in the same time very much inspirational guideline to sustainable construction approach as such. So again, covers design to construction to maintenance, and also that wraps up the circular building design as such. So first of all, what you should consider is whether you need to build something new or you do not. So repurposing, retrofitting existing buildings and constructions is something that you have to consider. So if you want to be sustainable, don't build nothing, actually. Yeah. But yeah, evaluate your options. Build for a long-term value, so increasing the utilization of your building if that's existing. So seasonal utilization, daily, nightly utilization. So how the building can be used 24/7 for different groups, various users and purposes. Design for longevity, design for adaptability. This is this modular system, design for disassembly. The needs may change even in your residential house. Think about it. Like, it's never like a ready product, you know, the house is never ready. You always have a change. The life changes and economy changes, and everything changes around it. So to create the maximum value out of the buildings, design for adaptability, and therefore design for disassembly and reassembly. Build efficiently. So this is the operational part. So build for less embedded operational CO2, so unnecessary components you don't need, and increase the material efficiency from CO2 perspective, from insulation perspective, according to use actually of the whatever the building and the building parts, in fact. Reduce the use of the virgin materials, so build with the right resources. Think about the locality first. This is why the 3-cycle system, I love it on that essence, because if you source it from local producers, local manufacturers, they again, come into the value chain and source from their local producers and partners. And this whole like a chain, works for a sustainable building and sustainable future of the built environment and environment in general. Carbon intensive materials still, as long as like we would like to believe the cement will become sustainable or more sustainable or recyclable. Let's be real, on how it actually works. So I urge you to look at the timber construction and eco materials and so on, and locally sourced materials. Yeah, and design for nature, that's another story. Architectural part and how it falls into environment, into socioeconomic situation, in fact, in regard to how the building is utilized and how the components can be crowdsourced, sourced, and so on. So yeah, I want to leave you with this whole and good, let's say, links or outsourced materials where you can look at if you need to find some keywords, need to read something, need to do and practice something around the circular design of the buildings. Thank you very much. Yeah, you can contact me here if there are any questions after the presentation or when you are watching it somewhere at some time. Thank you.
Okay.
Yes, floor to Ricardo, right. But you're gonna dig deeper into the efficiency and operation aspects.
Thank you, Gunita. Thank you. And good morning to everybody. But before starting, let me thank the invitation of Build Up for being present in this seminar. Let's try to see if I can control the presentation. I'm trying. Well, I don't know. Perhaps I need help because I cannot control the presentation. It's not working.
Patience, patience, patience.
Okay. Okay.
I think try with the mouse or with the keyboard, switch between. It took time for me to start as well.
Ricardo, remember to do one click on the screen and then you will be able to start moving.
Okay, let me try. Okay, it's working. So, starting for the presentations, my name is Ricardo Sá, and I'm a founder and director of Edifícios Saudáveis. In English means healthy buildings, a company with more or less 25 years of experience focused on energy efficiency. But we also work other areas, for instance, water efficiency, environmental quality, and building certification, both from the environmental perspective and the perspective of health and well-being. But in this presentation, I will focus on energy efficiency and certification, environmental certification. And let's start with efficiency, energy efficiency. Everybody knows what it is. I don't need to explain, of course, but I just want to refer that we work both with existing buildings, so from deep hardware refurbishments to the fine-tuning of building management systems without any kind of hardware intervention. But we also work during the design and concept phase of new buildings, helping owners and designers to take the best options. Of course, this is obviously strongly related with circular economy. It's all about reducing the use of resources, environmental impacts, reducing waste associated with energy production and distribution, and so on. I want to do two highlights from our very long-term experience. And the first one is related or is to stress the importance of the human factor, because it is very often possible to achieve very relevant savings without any major change in the hardware of the building. You don't need to change the central plans or the walls, but just optimizing the way the facility is being managed. Why? In our opinion and from our experience, because the skills of the operation and maintenance teams are not aligned with the sophistication of current systems and controls. And this slide shows an example. It relates to a medium-sized shopping center, and these savings were just because we make the fine-tuning of the ventilation system. So we install several sensors, make the fine-tuning of the parameterization, and we have this huge saving year after year. It's not a one shot, it's year after year saving this energy. So the importance of the human factor, we will go there again. But I would like also to, I think it's also very important sorry, I'm again trying to change the slide. Okay, sorry. Okay, also very important, but probably much less surprising, is the importance of early involvement of energy efficient experts in the design and construction of new buildings, or in the deep refurbishment of existing buildings. In our case, we start by defining a baseline building, so assuming, let's say, business as usual solutions, considering the market where we are operating, because we have some international experience. So considering the market where we are operating, which are the business as usual solutions for this type of new building? And then we define scenarios or variations to these baseline assumptions with impact in the energy performance. We are speaking about insulation, glazing types, lighting systems, HVAC systems, and so on and so forth. Then we calculate and discuss with design team and also with the owner. So when we paying for the building, we discuss with them the results. And I cannot go into the details in such a short presentation, but two highlights. The first one is to show you the importance of this. This is a real case, recent real case. And we can see that the difference between adopting all the best assumptions, the best scenarios, or the opposite, adopting the worst scenarios, it's 70%. It's really very relevant. Please note that again, after the building is built, this will be present year after year after year. And just to show you that the design building, the final version of the building, does not fit totally with the best case scenario, but it is clearly much closer to the best case than to the worst case. So it could not implement all the best solutions, but almost all. So the importance of this early involvement, I think it becomes clear from this. I'm again trying to change this. It works very well in before, but now it's not working so well. So another highlight, just to illustrate the link between water use and energy use. This is an hotel, and one of the alternatives that we discussed was the type of showers. So there are showers, let's say, efficient from the perspective of water use, with flows around 8 liters per minute of water. In the beginning, the owner was thinking about a much luxury, let's say. Indeed, it's not luxury, but a different shower with a much higher water flow. And this would have an impact because it's an hotel, so much of the water is hot water for showers, so it has the energy, of course. And we saw that this impacts and would increase the energy use of the hotel 5% per year. The energy of the whole building, not the energy associated with water, the energy of the whole building by 5%. And what I would like to stress is the difference with this scenario here. We double the insulation level when compared with our legal requirement. I'm speaking in Portugal, so it's a mild climate. It's not an extreme climate, of course. So we also evaluate the impact of doubling the insulation, and we have a 1% impact. So the impact of simply selecting good showers is much higher than the impact of extra insulate the opaque envelope. And this is very important to know when we are designing with a limit budget, as it is always the case. I worked for almost 30 years and I never saw a building without a very limited budget. They almost always they have. But last but not the least, to finish this part, also the human factor is very relevant in new buildings. And here I'm not only speaking about the technical competence of design teams, but also the motivation of the owner. And from our experience, we know that the results of this phase, okay, it was not the case in this very specific example that I'm showing to you, but the results of this phase are often suboptimal due to the split incentive effect. What is this? This is that the owner that is responsible for design and construction and to pay all those costs will not use the building and it will not pay its energy bill. So why should he spend money in energy efficient equipment? The bill will not be with him. It's one of the biggest questions that needs a good answer. And here, let's say, we can speak about the certification schemes because this can be a good impact on the split incentives can be one of the roles of good and widely recognized certification schemes. Because if the market recognizes these schemes and buyers or tenants assign value to buildings that are certificate, and typically this is the case, if the certification implies high levels of energy efficiency, amongst other things, but high levels of energy efficiency, so the certification will clearly be helping solving the problem of split incentives because the owner is investing and it will get some return from that investment. So let's focus on one of the certification schemes with which we work, LEED. Sorry, I'm trying to, so LEED, it was awarded by the United Nations for its contribution to enhance design, construction, and operation. Sorry. Okay, it considers or tries to consider all the environmental impacts of a building, so energy, of course, but also water, the materials, all the impacts, all the emissions to the environment. So it tries to take care of all these impacts and organize the impacts in different boxes, and then it defines a good practice for each box, and the building will be certificate according to the quantity of good practices that can implement. Very quickly, a very short description, but I think people are already also familiarized with this kind of systems. But we have a long-term experience with this. We were the first ones to make certifications in the Iberia Peninsula in Portugal. Here I show you an hotel. This hotel, which was the first platinum, which is highlight of LEED, was I show you because the figures I showed you before about the integrative design, about the energy efficiency in new buildings are related with this building. That's why I'm showing to you. We have also already certified very demanding and specific buildings. These are the hangars of Embraer, where airplane wings are manufactured. This is a winery for port wine. This is a refrigerated warehouse. All spaces are below zero, but even so, it's a LEED gold. This was really, really very demanding. And to finish this very small set of examples, this office building that was certified 2 or 3 years ago, that is amongst the top 100 of more than 50,000 buildings in the world, in what relates its score. It is also certified by WELL. WELL is another certification scheme that is complementary to LEED because LEED is focused on environment, WELL is focused on health and well-being, but we don't have time to speak about this. So where is the link between these certification schemes? I was speaking about LEED, I could be speaking about BREEAM, they are quite similar. Where is the, and there are others, of course. Is there any link between these certification schemes and circular economy? Of course it is. There is a lot of credits of good practices that are related with waste management, both during construction and operation phase, materials reuse, materials recyclable content, design for flexibility, design for the construction, all that is included in it. But also life cycle assessment. It was detailed in the last presentation, so by Gonita, so I will not go into details. Because I think most of you are familiarized with the concept, and it looks not only for the CO2 emissions, but for a wide range of environmental impacts. But what I want to show you is this. This is an example. This is really figures about the upfront carbon. Okay, not only upfront, but mainly upfront carbon. So carbon related with extraction and manufacturing of building products, construction products. The emissions associated are the emissions associated with the operation of this building, so the energy use of this building, are around 128 tons of CO2. So the upfront carbon from, so this, the carbon that is here, so just to put the materials to the building to be constructed on the construction site, upfront carbon equals 80 years of operation of the building. So the importance of upfront carbon. And this is not a specific and unusual case. It is usual because you can see here a benchmark. I don't know who the source should be here, sorry. But a benchmark of buildings in Europe, and the building that I was showed to you is not here. Also, it is not here. It is in the middle. So it's not a specific and unusual case. So the conclusion is, of course, that material selection and construction solutions are of the utmost importance to achieve efficient buildings. Trying to show the slide. I want to illustrate the importance of this with the final result. Okay, here it is. So just for you to have an idea, just look at the difference of choosing a low impact concrete. It allows a reduction, a huge reduction in the upfront carbon of the building, which equals or stands for 15 years of energy use during operation. So I think these are very impressive figures. And of course, they stress the importance of taking care of building materials, as was referred in the previous presentation. And finally, just to highlight that environmental impact reductions are not only related with CO2 emissions. The majority of impacts are reduced. And for instance, we are here speaking about circular economy and the depletion of resources. The depletion of abiotic resources, so mineral resources and fossil resources, is 10% just for choosing a different concrete, more sustainable concrete. So, to conclude, of course, there is a very deep relation between energy efficiency, life cycle assessment, certification schemes. They are deeply interconnected with circular economy, but that is not important. The important is that all these are tools in the path for sustainability. And the highlights I would like to do related with energy efficiency in operation is the huge potential for energy savings without investments. So the human factor, but the need to shorten the gap between hardware capacities and operation and maintenance skills. Also, the need to consider energy efficiency since the very beginning of the concept or the design phase. In what relates life cycle assessment, if timely and well conducted, of course it must be timely conducted when the decisions are being prepared. It's an important tool to guarantee that construction solutions and materials are part of the process of energy optimization. Fundamental. And then the certification schemes that are a very good and very effective mean to mitigate the split of incentives between developers and users. And again, if in time and well conducted, also a mean to enhance sustainability and building performance. Okay, thank you very much. Now I think it's the time for the next panelist. I give the floor to Ivan. Chris, thank you.
Thank you, Ricardo. A lot of greetings to all the viewers. I will start with some short info about Valamar Riviera. Valamar Riviera is the largest tourism company in Croatia and leading company in sustainability. Valamar was named 2023 Organization of the Year by GBC Croatia, Green Building Council of Croatia, for its commitment to green construction and sustainable built environment. Valamar has so far invested 1 billion euros in development of sustainable portfolio, and right now we have 36 hotels and resorts, 15 camping resorts with a capacity of 21,000 accommodation units, and we can accommodate about 58,000 guests per day. Today I will present our sustainability approach in project development and realization of at Valamar Amikor Green Resort. Valamar Amikor Green Resort is the first family resort built on Croatia Adriatic according to principles of sustainable development and in complete harmony with the environment. It's located on island of Hvar, just few meters from the sea and the city of Starigrad. In all stages of life cycle of the resort, we take into account the sustainability. That's why we added Green Holiday label. We offer 131 accommodation units. Structure is shown on the slide. The rest resort facilities also include Mediterranean restaurant, Sweet and Petit pastry shop, direct delivery from Mediterranean restaurant with alfresco delivery, aqua park with family, kids and baby pool, water slides, beaches, and sports and family facilities like 5 multifunctional courts, beach volley, tennis court, bike zone, stay free zone, and other. To achieve high level of sustainability, we needed to adopt sustainability approach in two very important categories of resort development. These are the sustainability in product concept and sustainability in service concept. Sustainability in product concept also includes architectural landscaping design, construction materials, green building certificate, interior and exterior design, energy management, and of course waste management, water management, and biodiversity. These are the main and crucial components of the eco-friendly touristic product. We will start first with architecture and landscaping design. In the earlier phase of project planning, in a phase of project of the defining of the project, we determined the need to change spatial plans. First step was the total urban reorganization that involves a revised spatial plan integrating innovative architectural and sustainable concepts, such as single accommodation buildings with one above ground floor instead of building one hotel, one building with all the service concepts located within. Also, we changed the planning parameters and construction conditions. Specific examples are the building's floor plan area proportion to the plot area, 0.35 instead of 0.4. The gross construction area to the plot ratio has changed from 1.2 to 0.25. So on 1 square meter floor plan, we can build 0.25 construction gross square footage. After the project completion, we achieved 0.23. Some other interesting parameters: average floor plan area per villa 56 square meters, average surface area of the villa surroundings 193 square meters. Also, very important that our master plan presented to local community, the local office for the urban planning and the building permits, and they all agreed with the plan, including the number of villas and guests. With these changes and decisions, we created the framework for our architects and designers to create a product that is in line with the local community. Carigrad is the oldest city in Croatia. This year they will celebrate 2,408th birthday with population of 2,000 people. So we respected the city, we respected the community and the environment. This was totally opposite from some average investor. Average investor, I'm sure, always is looking for the way how to maximize the plot potential, and we did just opposite. The second important category is construction and materials. Construction, so we have chosen prefabricated construction technology. We get the significant part of the construction process takes place in a factory under controlled conditions. We assure the easy dismantling and the circular economy. We reduce the demand for renewable primary energy, and one of the also most important conditions for the bidders, for the future contractor, is very high proportion of renewable primary energy in production process. Then after the construction, there is of course a decision about the materials. High proportion of materials with EPD, Environmental Product Declaration, or similar the certification was one of the main conditions for the bidders. Also, after the project completion, 95% of our materials were environmentally friendly. Basic building material was wood, what is something different and opposite to traditional construction methodology. The buildings were constructed using structural insulate panels, which consist of stiffened wooden panels filled with mineral wool. And finally, the bottom line and the result is a high level of LCC analysis, high level of LCA assessment. We significantly lower the global warming potential, the ozone depletion potential, photochemical ozone creation potential, and acidification potential in comparison to the other similar buildings, according to DGNB, and of course A+ energy class of the building. The third very important category is Green Building Certificate. We have chosen DGNB specific in its holistic approach. They take into account 6 criteria, sub-criteria: economic, environmental, technical, proceedings, and social, cultural, and functional criteria. We achieve a gold level in pre-certification process, and right now we are in progress for certification, where there is, of course, possible room for improvements, but I think we'll stay on the gold level. These are the achieved points or the level for every type of villa. And the certification process helped us. It was also like the checklist and the program guideline for the bidders, for the architects, and give you on the last step and on the project completion, give you the credibility. Third one is interior and exterior design. Involvement of users in decision-making process. We ask our guests what is their opinion about our mock-ups villas, and one of most important conditions for architects and designers is design for all. Barrier-free access to the building, high-quality floor plan. All communications are wide enough and illuminated by daylight, airing, and floor plan without barriers. Also, interior design, we use the furniture equipment with biophilic elements. Involvement of user in decision-making process was very important because they gave us very valuable feedback. And now we'll see the video. If Catherine, you can start the video.
This one, both of them they are welcoming, and so the big windows brings in a lot instead of the small windows. And take a look at the other house, you'll see a lot of wood, and that gives you a better impression. It's more eco-minded, and it's the future. There's a good protection in the insulation of both houses. You can see in the wall you have. And in the other house, there's two air conditioners to cool it down when being hot. I would like solar panels on the house so that you knew that the air conditioning in the warm period of the day would be fed the power from that one.
Für uns offener gestaltet, heller. Wir fühlen uns dort, also würden uns wohlfühlen, es ist ja noch nicht da, aber wir würden uns dort sehr wohlfühlen.
Das grüne Konzept an sich finden wir schon toll.
Richtig.
Dass man recycelt, ne? Dass man wenig
mit
Plastik bzw. gar kein Plastik. Das ist die Zukunft, denken wir auch.
Genau.
Ne?
Und beeinflusst
ja nicht so
dran,
oft.
ne? Genau, wie viel Wasser, wie viel Strom, also wir sehen das, wir wissen also, okay, ne, was verbrauchen wir eigentlich und man kann die Dusche zwischendurch ausmachen und so weiter. Also das ist ja das, was wir auch den Kindern beibringen. Genau. Und das ist hier eine tolle, ich sag mal für die Zukunft ein tolles Modell. Also definitiv, ob 1 oder 2, aber überhaupt, dass das so genutzt wird.
Auch dass die
über
Kinder
Sonnenenergie,
werden, ne? Dass die Kinder gleich wissen, so Mensch, wo kann man dann Plastik sparen oder gar keins benutzen oder ne?
Und das mit im Einklang mit der Natur, ohne dass viel Lärm gemacht wird, so die Häuser einfach schnell aufbauen, hinstellen, ohne dass jetzt Riesenhotels gebaut werden. Das will auch, glaube ich, nicht jeder mehr. Also für
ich
uns
glaube,
ist das
dieser individuelle Urlaub wird immer mehr kommen.
Ja, genau.
Ja. Ne, dass es überall ebenerdig ist und man keine Barrieren hat.
Genau. Also
sei man jetzt behindert oder man hat Kinder
kleine
oder ne, kleine.
Genau.
Ne?
Dass man da auch mit einer kleinen Karre nochmal drinnen dann, ne? Oder man hat vielleicht einen Kinderhochstuhl, den man ja fahren kann. Und das ist alles natürlich überhaupt kein Thema, wenn das ebenerdig ist. Wie gesagt, Teppichboden würde ich nie empfehlen. Also da sind wir uns einig, das muss auch nicht sein. Also
the feeling is very good because when you are you have not a plan to stay in a big hotel, but you want to have luxury and with a green feeling. This is it's a marvelous concept because it's very luxury, the colors are warm, and it gives you a feeling that you are outside, but with a lot of luxury.
Thank you. So the German family said they love the free barriers. They love the small building instead of the hotel building where all the serious concepts are located within, and there is a huge buildings with huge accommodation, a lot of accommodation units. They love the materials, they love the design for all, and they gave us really a great feedback for the further development of the project. And now I'll show you the energy management. Some of specific examples. For first, ecometer, displaying the guest energy consumption during their stay at the facility, all aimed to encouraging the guests to conserve energy and minimize their environmental impact. So we collect the data for every villa for day before. We calculate the average value. Then we show them how are they in comparison with other villas and other guests. And we show them the CO2 footprint from the day before. So the goal is not to scare them or criticize them. The goal is to lift up their environmental awareness and environmental impact awareness. Second one, we are using renewable energy sources such as photovoltaic cells, and we also purchasing green energy. We have thermosiphon solar thermal systems for hot water heating, and we have a measurement of CO2 concentration in accommodation unit. When is a value above 1000 ppm, guests will be alerted on the display of a smart room, and we suggest open the windows, open the doors. And we have also air quality measurements inside the resort. The result can be found on the TVs in public spaces, and of course on TVs in the accommodation unit. And the last category, very also important, waste management, water management, and biodiversity. Here I want to show you some specific and real-life examples. We have no plastic for the toiletries. The packaging is only recyclable. All plastic items are substituted with biodegradable options: slippers, straws, disposable underwear for spa treatments. Avoiding waste by not using plastic, providing waste separating facilities, refillable containers for shower lotion, body lotion, shampoo. Then a very important education training of the staff regarding waste separation and recycling. The waste produced is separate and passed on to external companies for recycling. We also control that process. Constant optimization of food waste. For example, this year we have planned to buy a biocomposter. Water consumption monitoring, water consumption per guest, and defining a reduction plan year by year. Water saving taps, shower heads, toilet flushes, spice and vegetable gardens. Some important note, 70% of our fresh ingredients are locally sourced. And education garden for children, where they can learn about sustainability. Hotel for insects, bird houses, for example. Your child will get on the check-in cardboard package to assemble a bird house. Making benches and other furniture from felled trees during the construction. No grassy areas that require irrigation. Marking and categorization of trees in the resort, and use of electrical buggies for transportation guests and goods around the property. Also, electric bikes are at rental disposal for the guests. You can see a photo overview of the destination. This is Island of Hvar, and on the right side you can see the position of our resort. On the left side is the photo of aqua park with family, baby, and family and kids, and baby pools and water slides. And here's Mara family facility where children can play and learn about sustainability with our animation team. You can see on the reception we have eco garden, and on the right side hotel for insects. Thank you for attention, and please be free to book accommodation in our Valamar Amikor Greens Resort. And that's all from me.
All right. Many thanks to our three speakers for this very impressive and very interesting presentations. We did receive some questions, and I would like to take a little bit of the time, allowing us to go a little bit over time, to at least address some of them. And I have a first question for Gunita. Can all types of wood construction materials be recycled? And if not, what is the share of wood that is currently used in construction that can be recycled?
Okay, so in fact, the recyclability. So first of all, you shouldn't recycle. You should avoid recycle. You should focus on reusing. So
yes, sorry, correct.
So the question regards to recycling or reusing?
I think it's both. I think you use reusing in your presentation, and that's what the question is focusing on. To what extent wood can be reused? What share of the total use can be reused?
The maximum. So so reuse of the wood depends on the design of the construction and use of the wood in the first cycle. So initial design. Okay. So as I said, if they are, let's say, load-bearing beams or columns or engineered elements, again, different kinds of engineered wood have the different loading and expiry, let's say, or a life cycle of that wood. But it is very important to digitize that load in the first cycle to understand how it can or how much it can be used in the following cycles when it is demounted, reconstructed, or done. So that is on reuse side. Depending on the characteristics of the wood constructions, because it's not just so when we say engineered wood, we say CLT, GLT, so cross-laminated or glue laminated timber. So first of all, you have to understand that the wood timber engineering has also very much evolved, and it's not just log houses or garden houses that we can build from wood. So the specifics engineering power of the wood has also been extended to minimize the need for a wood, let's say in this case CLT, GLT. So that is the first side, depending on how it is designed. Usually you can maximize, you can actually reuse all the materials of the wood in the following cycles. The second question was on the recycling. So we can say there are two stages or two important timelines that we have to consider. The first is the existing built building, I don't know, bank, we would say so, or everything that is built until this point. And then there is a new construction, new buildings. So when we look at the past, so everything that is built from wood in the past, not everything can be reused or recycled. And this is the question of adhesives, actually chemicals used to unnecessarily work with the wood. Then I would say a very not conservative, but outdated, even scientifically outdated argumentation of wood against fire safety. Comparing with other load-bearing materials, for example, steel, concrete. Okay, so scientific research now has very much extensive information about how what are the wood preferences in fire situations and in its strength actually that overcomes the other kinds of materials, especially for residential or let's say public buildings as well. And that has required in many legislations to work with wood with pollutive adhesive, which then limit the recyclability of the wooden materials. Second aspect of that is the techniques, as I mentioned as well with the modular housing, like how wood is actually connected with other materials. So is it, for example, insulation material, is it like nailed to it, or it has easy to disassemble construction, or let's say some sort of cover kind of laid material, is it melted to the wood, or you can again disassemble it from it, and let's say recycle this polymer kind of material and also reuse the wood if it is not let's say used with adhesives. So building techniques and practices, knowledge how to work with the wood affects the reuse and recycle of that material. Therefore, very much affects the life cycle saving in terms of cost and carbon in the calculations and also in the perspective.
Maybe a short question to wrap this topic up, because it's a super interesting one. To what extent, from your impression, are the production, so the industry sector, for the production of wood construction materials, but also the construction sector itself, on board and ready skill-wise, knowledge and skill-wise, to approach wood, let's say again, from the perspective of reuse and recycle?
Very interesting question. I would have very extensive actually answer to this.
Let's try to keep it short due to the time, but I don't want to skip this one because it is a very important one.
Yeah, to what extent I could elaborate in very detail, but I'll just describe it whole. So let's say due to the fact of CSRD, the directives, the taxonomy, the financial ability, sustainable finance, the access of the finance in the nearest future, wood construction, wood production, we would say so, producers are alerted to that they actually have to, first of all, enter the circular economy principles. So they kind of understand that in the next 5 years, they will have to consider this fact. But let's say only 10 to 15% of in Latvia, I like there's like, I don't know, 100, 150, I think 30 producers that I talked with. So only 10 to 15% of them have actually implemented that in their strategy, the 5-year strategy. And just a couple of them have actually laid out activities. That means, let's say, work on the byproducts. So see what are the new products coming out from the byproduct. Re-engineer, or let's say look over their existing designs to be more, let's say, designed for this assembly ready. So they kind of are in the next stage, but the very first awareness to that the producers have is that these all regulations and let's say regulations that they will have to be compliant with to compete in the market are connected to circular economy and not just energy efficiency. So not just making it more energy efficient would like kind of take them to this green path. So they don't really consider these aspects that I try to emphasize: design for disassembly. First of all, looking at their buildings, their products, not as waste. At the moment, from the questionnaire, let's say they give the guarantee in a maximum of 15 years of their product, like a modular prefab, but like building should be 50 to 100 years, even more. And when asked about do they take back, let's say, the building parts, or after, if it's not necessary, or it is demounted, the building, or let's say the event, like the garden house or something from the wood, they don't take it back. So that means they are not part of the circularity. They can't reuse it. They look at their product as a waste at the very initial stage when they create it. And this is a big problem to consider, even within these like kind of very sort of potentially sustainable manufacturing line, I would say so, you know, wooden buildings which present such a potential. And another aspect to tap on is, of course, the process itself, so that they don't have to innovate everything within their factory plant, their manufacturing, their company, you know, and then that differs big companies from small companies. This is this circular approach to whole construction and basically leveraging demand and supply in that context. And of course, the public demand is the one that kind of shows the temperature and what is necessary. So if the state, you know, is ordering the sustainable buildings built from wood, especially kindergarten schools, that will present the eco climate for, let's say, future generations, then also manufacturers should sort of adjust and understand that that's not just one manufacturer that will deliver all those kindergartens, or even one. So the process thinking, rethinking, not just patching the things on engineering side or production side, or using just wood, you know, for sake of carbon sink, but understanding that it's a holistic approach and requires a lot of players. And that's why sustainability, it's not a silo thing, it's a very cross-discipline and cross-company, cross responsibilities.
Okay, I think a big part of your answer indeed doesn't only apply to wood, but it will also apply to other construction materials, obviously. Okay, many thanks for your replies. Let's move to Ricardo for a question. Ricardo, is it usual to combine upfront carbon with operational carbon to evaluate energy efficiency opportunities?
I would say no, it is not usual. If you are speaking about when we are thinking in the refurbishment of a new building or to increase its energy efficiency, it's not usual. And in some cases, it is not necessary. In those cases that I refer about fine-tuning without relevant hardware investments, it's not necessary because upfront it's minimal. But it's true that when evaluating large or deep refurbishments, for instance, when evaluating the change or a deep refurbishment of a thermal plant that produce water with very big equipments, very heavy equipments, then it is very important to perform those kind of studies, because the savings, the upfront carbon of the new equipments that will refurbish the actual, the upfront carbons will make a big offset to the savings. And so I am nowadays I have very reserves to propose the change of new equipments for other new equipments that are much more efficient, but have the upfront carbon in that. So no, the answer is no. It is not always necessary, but sometimes it's very important and should be more widely used. Catherine, you are off.
Excuse me, forgot to unmute, apologies. And a last very quick question, since we are pressing time, and I would like to ask another question to Ivan as well. We got from the audience also a question asking which energy performance software offers the best integration with Revit for building energy modeling and analysis. And more specifically, how well does each software handle assumptions, material properties, and HVAC systems when importing from Revit? It's a very long question. Additionally, yes, how effectively do these tools leverage Energy Plus for accurate simulation results? And are there any common issues or limitations to be aware of during the integration process?
Okay, I must first of all make a disclaimer. I'm not an expert in all the energy simulation software that are available. Mm-hmm. I can speak about the software that we are using, which is EAS, Integrated Energy Software, something like this, EAS. Well, I think the question is not, of course, the software has lots of it's not perfect, no, and we notice very often some problems, mainly when trying to simulate systems. So the HVAC, cooling towers, variable speed drives, sometimes the software does not give us good results, but I think that more important than the software itself is the user and the quality of the inputs that are there. And let me tell you that we use these softwares to perform benchmarking and to, when we are making the energy management of a building, we calculate benchmarking for the different energy meters using these kind of softwares. And typically, after a period of adaptation and fine-tuning, we can achieve very good results. Of course, it's much easier in some buildings. For instance, shopping center, very easy. Supermarket or hypermarket, very easy. Then in other, for instance, residential buildings, very difficult because it's very dependent on people behavior. So the answer is I cannot compare all the softwares because I don't know all of them, but it is possible to have very good results with them. Not perfect results. Okay.
I'm warned that we ran out of time. What I would like to raise is that maybe we can provide you with the questions of the audience that we haven't been able to answer. If you could take a brief look on it and see if there is something important that hasn't been addressed in the presentations yet that maybe we can include into the publication on the website later on. I'm sorry, Ivan, we will have to wrap up.
It's okay.
I had 3 questions, super interesting questions for you, but they will have to wait.
You can send me and I can answer later, yeah.
Perfect, many thanks. So a big thank you to all 3 of you and to the audience for attending today's webinar. And as a reminder, you will be able to find the recording of today's webinar on the BuildUp portal and our YouTube channel in the coming days. Later on, BuildUp will be back with more webinars. We have a few in the pipeline in the coming weeks, so keep an eye on the BuildUp calendar of events and our social media for updates on these. Also, super important, be sure to register on the BuildUp website to be able to share and disseminate your own content on our platform and follow us for social media updates. We wish you all a super pleasant continuation of the week. Thank you and goodbye.